Welcome to this explainer. Today, we're diving deep into the art and, honestly, the absolute science of operational headcount planning. We're going to take a journey from the hyper-granular stuff, like figuring out exactly how many hands you need on a warehouse floor in a specific hour, all the way to the back-end SQL data extraction that makes these massive logistical operations even possible. So, if you've ever wondered how major fulfillment centers avoid complete chaos, you are definitely in the right place.
Okay, let's dive into this. Picture this. You're staring down a massive facility, and it's got an absolute max capacity of processing 23,000 packages every single day. The stakes here are huge. If you understaff, well, packages pile up, delivery windows are completely missed, and your customers get angry. But if you overstaff, you're just burning through your operational budget and crushing your profit margins. Getting this right isn't just a nice-to-have, it's an absolute financial necessity.
To solve this puzzle, we've got a clear roadmap. We'll start with the immediate operational challenge, move into calculating the exact hourly need, explore how to optimize our shift costs, zoom out to a 12-week long-term strategy, and finally, look at the power of the back-end data.
Section 1. El desafío operativo, grounding the daily operation.
Think of daily shift optimization like a giant jigsaw puzzle. The pieces are time, people, and money, and they all have to fit together perfectly to leave zero gaps. Now, every operational puzzle has fixed constraints. For this specific facility in week 27, we're working with 4 key variables. First up, the total volume forecast for the week. Second, the processing curves, which basically tell us historically when those packages actually arrive, hour by hour. Third, the productivity rates of our workers. For example, a water spider handling standard conveyable packages can secure about 2,000 packages an hour. But if they're handling heavy, non-conveyable items, that rate plummets to just 45 an hour. And you know, nobody wants to be the one explaining why packages are stacked to the ceiling just because we forgot to schedule the heavy lifters. And finally, our absolute ceiling. That site capacity of 23,000 packages a day.
Section 2. Calculando la necesidad, the hourly problem.
So, knowing those constraints, we transition to calculating the exact hourly need. This is where we really get into the weeds of the daily schedule. And here is our magic number, 34. When we apply our package arrival curves against our productivity rates, we discover that this facility hits its absolute maximum need of 34 associates on Tuesdays and Thursdays at precisely 1 p.m. That right there is our peak target. Everything we plan has to ensure we can hit 34 people at that exact moment. But that 34-person peak isn't just 34 random bodies walking through the door. It's highly, highly specific. Breaking the numbers down, that 1 p.m. requirement actually calls for 8 sorters for conveyable items, 4 people managing the buffer, 6 in unloading, and highly specialized roles like 10 water spiders who deal strictly with non-conveyable, oversized freight. Every single person has a designated rate and a designated role.
Sección 3. Optimización de costos, balancing coverage and budget.
Knowing we need 34 people is really only half the battle, right? Now we have to balance this perfect coverage with a very tight budget. And here's the main complication. You can't just hire 34 people on the exact same schedule. We've got an entire catalog of shift types to pull from. Full-time workers on a 6-day on, 1-day off schedule cost $3,950 a week. A 5-day on, 2-day off schedule costs slightly less at $3,900. Interestingly, a condensed 4-day work week actually costs more at $4,000, which is a fun little piece of irony. And then we have day laborers, or diaristas, who cover single specific days for $920. Because of all these variations in rest days and weekly costs, building a flat schedule is incredibly difficult.
And this brilliantly illustrates why you absolutely have to mix schedules. If we took the easy route, let's call it Scenario A, and just hired everyone on a 6-day full-time schedule, our total weekly cost would be $132,190. But by strategically assigning different days off using a mixed approach in Scenario C, we can drop that cost down to $131,740 for the exact same coverage. Now, it might seem like a tiny drop on a weekly basis, but stretch that over a year across 50 facilities, you've literally just saved the company millions.
So the model's optimal mix locks in 24 full-time associates on a 6-day schedule, 9 full-time associates on a 5-day schedule, and then we surgically deploy 2 single-day laborers to cover those extreme volume spikes on our Tuesday and Thursday peaks. We hit 100% coverage at the absolute lowest possible cost, with 0 unnecessary overstaffing.
Section 4. Estrategia a largo plazo, conquering market volatility.
Now, operations don't live in a one-week vacuum. Because when we zoom out to a 12-week horizon, the real world throws a massive twist our way. Market demand fluctuates wildly. We're talking 5 to 10% every single week. So how do operations handle that volatility without descending into chaos? The source outlines what's called a base plus flex model. Instead of constantly hiring full-time staff during a busy week and then firing them during a slow week, which completely destroys company morale and incurs massive hiring costs, the model dimensions a stable full-time headcount to the 60th percentile of our forecast. For any demand that spikes above that base, the site simply flexes up using temporary day laborers.
Looking at a simulated 12-week plan, you'll see the base full-time headcount stays relatively stable in the low 30s. But notice what happens in week 31, week 32, and week 38. The forecast suddenly jumps. Instead of frantically onboarding permanent staff, the model automatically triggers the estimated need for 1 or 2 day laborers to act as a buffer. It's an incredibly robust, highly resilient system.
To ensure this 12-week plan doesn't go off the rails, operations track the staffing efficiency rate, or SER. This is your real headcount divided by your planned headcount. The target is a very tight window between 95% and 105%. Think of it as a strict alarm system. If that number drops below 90%, the facility is going to face a severe, immediate backlog of packages. On the flip side, if it exceeds 105%, the business is essentially just burning cash on idle workers.
Section 5. El poder de los datos. Tracking operations with SQL.
Now, for the final piece of the puzzle. We've talked a lot about volume forecasts and historical processing curves, but the reality is none of these brilliant operational decisions are possible unless a data analyst can actually extract that history from the back-end database. To see how this works, let's look at a practical SQL exercise directly from the source material. The objective here is to identify countries where total sales in 2024 were over $500. Why does an operations planner care about that? Well, because forecasting future staffing needs requires you to group your historical volume by region and filter it by specific timeframes to spot those critical trends.
Okay, let's move to and see how this builds in the code. SQL is really just logical steps. First, we join our orders and clients tables together so we can actually link a purchase to a specific geography. Second, we use where to filter the timeline down strictly to the year 2024. Third, we use group by to aggregate all those individual sales into total buckets by country. And finally, we use having to filter out any aggregated country total that falls short of our $500 threshold.
And bam, here is our correct, verified output. The code successfully aggregated the individual order lines and proved that Mexico hit $700, Colombia hit $600, and Spain hit $550 in the 2024 window. This is the exact kind of structured data output that S&OP teams rely on to build those complex headcount models we just walked through.
So from calculating peak hour sorters all the way to writing back-end SQL queries, operational success really comes down to combining rigid, exact math with flexible staffing solutions. You have to understand the underlying data to build the ultimate schedule. So I'll leave you with this. How will you apply these base plus flex models and data aggregation strategies to optimize your next forecast? Keep analyzing, keep optimizing, and I'll catch you in the next explainer.